Over the last several decades, there's been a lot of development in solar and electric vehicle technology. Have you ever heard that solar and EVs produce more pollution and waste to produce the batteries and have larger humanitarian crises than the alternatives? Have you also heard that the solution to all the future's problems is to put solar panels on every roof and for everyone to drive an EV? Our previous videos on capitalism, politics, and the environment have started to lay the groundworks and foundation towards a culminating series of videos that is going to end up leading towards a future video on the pathways to decarbonization of our future, the solutions for the crisis that we find ourselves in. For us to get there, we have to continue laying those foundation bricks, and today we're going to focus on solar power and electric vehicles. I'm Keith St. John, a husband, a hockey dad to 3 boys in Ontario, Canada, and a mechanical engineer with 19 years work experience in the sustainable and clean energy sector. And we're going to talk today about debunking some myths between solar and EVs. Let's get going.
It's an enormous privilege to be here on Earth Day to join in signing this historic agreement. I was a young organizer and speaker not so long back from Vietnam on the first Earth Day in 1970. It's fair to say that all of us could feel an extraordinary sweep of emotion and joy at the moment in Paris when 196 nations simultaneously said a resounding yes. We will do our part. We will live up to our responsibility to future generations. Paris marked the moment when the world finally decided to heed the ever-rising mountain of evidence that had been piling up for years. It marked the moment that we put to rest once and for all the debate over whether climate change is real, and began instead to galvanize our focus on how, as a global community, we are going to address the irrefutable reality that nature is changing at an increasingly rapid pace due to our own choices.
In order to meet those targets, countries around the world are attempting to find ways that they can reduce the carbon emissions. The largest emissions in the world in the manufacturing industry, energy production industry, transportation, and agriculture has led a focus on the electrification of transportation and as well clean renewable energy sources. And when new technology is going to replace old technology and there's money to be made and lost, misinformation campaigns are going to be created in order to sway public opinion. This transition from a fossil fuel-based economy to a green one is already underway. It involves a giant shift in the way that we generate and use energy for all types of purposes.
The only thing green about renewable energy is the money it makes for billionaire banks right around the world. And the enthusiasm you see for renewable energy from banks, from investment houses, you've always got to be a little bit cynical about why are these people who are otherwise, we thought otherwise, only interested in the mighty dollar, why have they suddenly had some conversion and want to save the planet? They haven't had a road to Damascus moment. They're just making lots and lots of money on the backs of the power bills that you pay every quarter.
I want to bring Craig in here. I'll talk to my producers now if they can find me this grab of the wind turbines and the cost, the emissions cost. What I found so striking, Craig, was how carefully Moore busts the myth that renewable power is free. I mean, we're told that often the wind's free and the sun is free, and he talks about the emissions needed to produce these turbines and solar panels. It's a farce, Craig, you know, built in China, Chinese jobs, right. Australian coal burnt over there, emissions counted. We've got to count them more and more. They come here on our subsidies, they go up, they last a few years, they come down, and the cycle repeats itself.
Well, what we hear, Peter, is these so-called green energy creates all these green jobs. And what Michael Moore's film does is also expose that it's just a complete myth. And Moore's film, what makes it so important, as you said, he's a character from the left. This is the moment where they say the emperor has no clothes. And he exposes Everything about green energy is simply a fraud peddled by a whole lot of swindlers that are making an absolute fortune out of it. And ultimately, it's not even environmentally friendly. As you said, all these wind turbines and solar panels, they have a life from 15 to 20 years. We're going to have to build giant holes in the desert to bury all these wind turbine blades and to start burying all these solar panels when they come to their end of life.
Matt, you were, again, in the book review or the film review you wrote for the Specky, you reminded me every megawatt of wind power generated requires 870 cubic metres of concrete and 460 tonne of steel. In comparison, each megawatt of natural gas requires 27 cubic metre tonnes of concrete and 3.3 tonnes of steel. This is not just the economics, but it's the emissions and the cost of renewables that people don't factor in when they're marching in the street and telling kids to miss school.
We think, you can see wind turbines are massive big towers. They do interrupt the environment. But solar panels themselves, to make the film, the silicon that goes in the solar panel, they have to heat quartz up to 1800 degrees centigrade. And the only way currently to get efficiently that kind of temperature is, guess what? Using that little old, reliable black rock called coal. That's how they do it. They use coal, and probably from our coal fields, because we have that type of coal here in central Queensland. They use coal to make that silicon that ends up on your roof, and everybody here has a warm glow thinking they're doing something right for the environment, but really what's on their roof is coal.
It wasn't so long ago, Craig, coming out of the Howard years and the renewable energy target.
The myths and the conclusions that they generate are often centered around one of two core assumptions or failings. The first is an assumption of a dirty grid, and the second is an ignorance that these technologies are replacing current technologies and the failure to account for the footprint of those existing technologies that these are displacing. Let's get into the details though. Myth number one, that renewable energy takes more mining than conventional coal, oil, and gas industries. Myths like this are propagated from graphs like this that were created by the International Energy Agency and the misunderstanding of what this graph, for example, represents. This graph shows what mining inputs are required for all of the sustainable energies, and then including coal and natural gas to compare against, in terms of kilowatt of resources required per megawatt of production facility. Graphs like this show that the production of a wind, solar, nuclear facility takes significantly more materials than to create a coal and natural gas facility. However, this chart only shows the minerals needed to actually create the power plants themselves. Once a wind turbine or a solar panel is constructed, it will continue to produce power with no further mining needed. Their fuel, wind and sunshine, is only provided by nature. Fossil fuels, on the other hand, require constant mining and supply of fuels in order to operate. This chart only looks at kilograms per megawatt and not kilograms per megawatt hour. But when you account for the fact that the solar panel will produce power for 25 years with no further fuel or mining required, but the coal plant, for example, needs a constant supply of new fuel, the graph changes quite quickly. The amount of coal required to run a coal plant is roughly 1.2 pounds per kilowatt hour or 1,200 pounds per megawatt hour. If we run this coal plant for as long as that solar panel produces power, we need just over 119 million kilograms of coal to run that plant. Adding that coal onto the graph gives you this. Now, one thing that graph doesn't estimate is the fact that different materials require different amounts of energy to actually extract out of the earth. Thankfully, Rice University did a study on exactly this, and they found that just installing 1 gigawatt of wind capacity to replace the coal in Texas reduces the total mining by 25 million tons over 20 years. And in fact, they found that 5 times more power is produced by mining materials in order to generate wind instead of coal. And the story is even better for solar and nuclear. So yes, mining for solar panels and wind does create waste, and these things do end up in landfills. However, when you look at the alternative, if you don't have solar and you don't have wind, the environmental impact on mining, of creating these facilities and running them, is much higher in coal. What's the story for natural gas? The story for natural gas is much more favorable, and in that reason, we're going to actually talk about this in my future video on pathways to decarbonization of our future, where natural gas actually will play a role in how we transition into a greener economy. However, it's important to mention that natural gas releases a ton of methane, as methane is one of the biggest downsides of natural gas. And because methane is such a potent greenhouse gas, one of the biggest, quickest, and most impactful things that we can do to reduce climate change is actually to focus on methane leaks from natural gas pipes, fittings, valves, and flanges. And this is where an organization like MethaneSat comes in. MethaneSat is going to be providing regular monitoring of regions accounting for at least 80% of all global oil and gas production, measuring emissions over large areas and specific sites. It'll see concentrations of methane as small as 3 parts per billion. In this way, engineers can go and find the source of the leaks and seal them up and reduce methane emissions. The second area of rampant misinformation is in the carbon footprint on constructing and manufacturing solar panels. This comes from 2 factors. The first is using dirty grid misinformation. The building of new solar, wind, nuclear, and hydro is an attempt to clean up our current dirty grid. The first round of solar panels have been produced using a largely coal-based grid. However, the more solar panels that are created, and especially looking into the future, the grid will get cleaner and cleaner, and the carbon footprint associated with the manufacturing of the solar panels is going to reduce every single year. Commonly, the carbon footprint required to build a solar panel is extrapolated over its 25-year lifespan, and the next solar panel required to replace that is using information based off of today's dirty grid. This is a real sneaky and clever way in order to actually miscount how much carbon is going to be used to create the solar panel, whereas the mining of coal, as we saw in the first graph, is always going to be required to be done using coal-based technologies. In fact, cleaning up the carbon footprint of all mining, including lithium and cobalt that's used in batteries and solar panels, is one of the largest challenges in engineering in order to clean up and create clean energy systems. However, it's still cleaner than the alternative, which is coal. But using this old dirty grid assumption in any kind of cradle-to-grave assessment that looks at solar panels produced in the future is just straight up misinformation and lies. Additionally, there are 2 main types of solar panels. There's monocrystalline and polycrystalline. Both require substantially different manufacturing. And sometimes this isn't evident until you dig into the actual data that they're using in their conclusions. But sometimes I've seen people use the lower efficiency rate of the polycrystalline panels, but then combine that with the cost of production of the monocrystalline panels. I've also seen it where they use the more expensive monocrystalline panels, but then they'll use the lower lifespan of the polycrystalline panels in the same report. Okay, so that's solar, but we've seen similar arguments being made with electric vehicles and, for example, cobalt and lithium in the batteries. These are 2 really important topics, and my personal take on the 2 things that need to get solved, because these are the humanitarian crisis that are part of the production and transition from our current economy to a green economy. These things need to get solved before we just go out and produce a ton of EVs. And this is where we get into things called environmental externalities. An environmental externality is a cost paid by a third party who has nothing to do with the actual transaction. Now we come to another semi-myth. What are the human rights implications of mining lithium and cobalt? A major concern for cobalt is that 70% of the global cobalt supply and nearly half of all known global reserves of cobalt come from the Republic of Congo. A lack of regulations has led to extremely dangerous mining conditions there, and it's often done with child labor. This needs to get solved as quickly as possible, but thankfully there are solutions on the horizon. One avenue that researchers are investigating is developing new sustainable lithium batteries. For example, lithium iron phosphate batteries remove the cobalt from the equation completely. These lithium iron phosphate batteries are not something that's coming in the future. It's something that is here today. And half of all Chinese EVs and half of Teslas sold in the year 2022 have used this lithium iron phosphate battery technology. Slightly delayed from this, there's also research being done into manganese substitutions for cobalt in the battery technology itself. Now, I've labeled this one as a semi-myth because although the human rights implications of lithium and cobalt mining are very real, serious issues that need solving. The alternative of mining coal, oil, and gasoline still has similar human rights implications.
In the Jaintia Hills, Bikash Chetri is getting ready for the day ahead. While children elsewhere are putting on their school uniforms, Bikash is getting dressed in his work clothes. Bikash and his friend Lakpa live next to a coal mine, and this is where they spend their days, underground. It's a steep, slippery climb to the bottom of the pit. But the real journey starts once they get there. In the Jaintia Hills, they call this a rat hole. Bikash and Lakpa, who's also known as Maklo, slowly make their way through a narrow labyrinth of tunnels stretching 50 metres into the earth. When they come across other miners dragging carts of coal, they have to squeeze against the tunnel walls to let them pass. Boys will spend hours at a time cutting coal down here. It's hot and low on oxygen. They have no training, no protective clothing, and no compensation if they get injured.
कैसा लगता है अंदर जाने डर लगता है क्यों डर लगता है
मालूम नहीं ताल से मारेगा क्या क्या होगा पत्थर गिरेगा उधर से ऊपर से
डेंजर ही हो सकता है अभी जगह में गिर जाएगा ना क्या रास्ता में ऐसे ही फटा हुआ है ऐसा उसका पता नहीं कब गिरेगा.
This is just one of thousands of small, privately owned mines in the northeastern state of Meghalaya. The industry is unregulated and unsafe and relies on cheap migrant labour to do its dirty work.
The fact that so much more coal, oil, and gas is needed to sustain and run a similar sized economy on coal, oil, and gas means that the human rights implications are pretty much the exact same in both situations. This is just something for humanity to solve, not necessarily a detractor or pro from either the EV side and solar panels or from the coal and gas side. This is just something we need to fix. One of the benefits of scaling down the production cost of things like solar and battery technology is that it actually makes these energy options affordable and available to lower income countries. And in this way, access to more clean and cheap energy actually brings them out of poverty. Bringing families out of poverty reduces the desperation of these communities that would otherwise lead them to send their children into mining coal and cobalt. Studies have actually shown that when you include these externalities in the production of solar and EVs, but you also include the externalities of coal, oil, and gas, that it actually only further supports the case for moving towards solar and EVs. Currently, China produces over 50% of the world's solar panels, and this is what China's energy distribution looks like, with more than 50% of their energy distribution in coal. So to take this and create a conclusion that this is why we shouldn't create solar panels, instead of this is why we should create and expand manufacturing for solar panels locally, is a conclusion that just requires so much mental gymnastics that I just can't even comprehend it. Now, in terms of power production, the world can't simply transition to all solar, and there's very real reasons that I'll get into in the Pathways to Decarbonization video, but I'll touch on them briefly here. One reason is that it's not enough to just talk about megawatts, what the demand is and what the supply is, in order to see if you've got a viable energy solution. The maneuverability of power is very important. And by that I mean more than the fact that sometimes the sun doesn't shine and sometimes the wind doesn't blow. When somebody turns their light on in their house, that actual increase in demand has to be matched immediately by the grid, by an increase in supply. Nuclear power is fantastic at providing baseload power, but a nuclear power plant runs optimally either guaranteed in a poisoned shutdown state or running at 100% full power. These are the two areas where nuclear is its safest. For that reason, when someone turns a light on and that power demand has to get matched by supply, it has to come from a maneuverable source. Traditionally, coal and natural gas have been fantastic for this because you can basically just throttle open a valve, let more natural gas into a burning furnace, and create more power. In order to have the same engineering mechanics on a grid that doesn't have coal and gas, you really need storage technologies. So a key part of the future's energy mix is going to be battery technologies, whether that is actual batteries or natural-based batteries, such as when you have a low pond and a high pond, and in the daytime you run pumps off of solar panels in order to pump water up to the pond, and at nighttime you open a valve and you run the hydropower back down to generate the electricity. The problem with that is none of those things are 100% efficient, and energy is lost in both processes. So it's important that this is factored into the capacity factor of, for example, solar panels and wind turbines when we forecast forward into a grid that doesn't have coal, oil, and gas. For the same reason that it's disingenuous when we consider a dirty grid on the manufacturing carbon footprint of solar panels and EVs, for the same reason, we shouldn't assume that the futuristic grid does not have losses in terms of this energy transfer between batteries because of the replacement of coal, oil, and gas. Another key aspect playing into the future energy grid mix is going to be when the demand is. Currently, peak demand happens roughly during daytime hours when everyone goes to work, turns on office buildings, and manufacturing starts up. In the future, when the entire transportation industry switches over to electric vehicles and people aren't buying gasoline anymore, but they're charging their EVs over the nighttime because they're at work in the day, the energy demand is actually predicted to swap. And energy peak demand is actually going to transfer from roughly in the afternoon during the day to just before people leave to go to work in the morning. And because of this, projections looking forward to what the future energy mix should look like absolutely needs to include nuclear power as a base load in order to provide this power, because the effectiveness of solar to play into a market where it's now producing power not at peak demand times is going to reduce the use case of solar slightly. It's still going to be a fantastic technology. It's just not the technology that we need to throw 100% of solar and call ourselves green. So the next myth is not necessarily a myth against solar, but it's actually a lie of omission. When people don't discuss water, fossil fuel energy production is a very water intensive process. The US energy system alone consumes approximately 58 trillion gallons of water each year. Large amounts of water are required for energy production at power plants, at the fuel extraction stage, refining and processing, and during fuel transportation. This dependence on water is not only problematic because water is a limited resource, but also because it creates water pollution. The next myth is another lie of omission, and that is the actual health impact on human beings based off of the two industries, coal or solar. The mining and production impacts are roughly the same as previously discussed. However, once a solar panel is manufactured, it sits there creating power in a field or on top of a roof. A coal power plant, however, emits not only pollution to the workers or the staff, but the entire regions around the actual power plant. These emissions cause real human health impacts based off of the pollution. This is from the US Department of Health. The next myth that's often propagated, although admittedly probably unintentionally, is the fact that the cost of production of solar is constantly dropping. And at any given time, a study that compares the cost of solar to the cost of coal, for example, will use the data of the day. But it's important to know that this is constantly getting better, as shown by this graph here. Now, I've seen studies that use costs for solar in the 30 cents per kilowatt hour range, and these are outdated by at least 1.5 decades, and current costs of solar are somewhere around the 5 cents per kilowatt hour range. This myth is further propagated when the costs of coal do not include impacts on the environment and public health. Ontario did a recent study on including these assessments into the cost of coal, oil, and gas. The study was done in order to include these costs into the operating costs of a coal, oil, and gas facility, and it was found that the total cost of running the coal plant was 16 cents per kilowatt hour when you include human and environmental factors into the equation. Okay, the next one's not going to be a myth per se, but like a misrepresentation of what the actual reality is. And it's born in stories like this by Forbes, where they show a poor person walking around a landfill and how the landfill is full of solar panels and wind parts. I don't know about you guys, but I know composting pretty well, and there's a lot of heat being given off in that garbage pile, and I'm seeing a whole lot of food waste, and I'm not really seeing a whole lot of actual solar panels and giant manufactured parts. Now, this one is an engineering challenge that we have to face, and while there are some pro-solar proponents that state that up to 80% of solar panels can be recycled, technically they aren't done right now because it's not economic, and a lot of what you can recycle is the glass. However, the situation is currently much better than what a lot of detractors will say, and it's only going to get better as the years go by. In fact, recycling of solar panels and EVs, especially lithium batteries, is being done right now, and as of 2022, it's a $170 million industry. It turns out that when you're building a lot of EVs, that recycling and getting back some of this lithium and cobalt is very, very valuable. Studies done to show that it is not economical to recycle solar panels and lithium out of EV batteries have one fundamental flaw and assumption in them. And that is that for batteries, they look 7 years in the future for when they need to get replaced. And for solar panels, they look 25 years in the future for when they have to get replaced. But they use the data from the day of the study on the current economic demand for the lithium and the minerals out of the solar panels in order to determine the market demand for these materials. And with all major car manufacturers moving towards EVs, Tesla building gigafactories, the demand for these materials is increasing every single year. And a study by the Rystad research firm estimates that this market to grow to $2.7 billion by 2030. This represents an increase of 1,588% of today's number, and today's number grew by 50% of last year's number. So now take everything that we've said in this video and project forward to what humanity should be doing in the future, but use future economics. Use a clean grid, manufacturing solar panels and EV batteries, yes, using some coal for the mining process, but that mining process is now going to be reduced going into the future. And then also include clean grid for the manufacturing of all the solar panels.
have a windmill anywhere near your house, congratulations, your house just went down 75% in value. And they say the noise causes cancer.